This is your Daily 10. Calculator, video 10. Make sure you pause the video and attempt each question before you watch the solution. So here's your first question. So all we need to do here is to work out which of these is equivalent to 2.375. Well, if you remember, when you're working out a fraction or changing a fraction into a decimal, all you need to do is divide the top number by the number at the bottom. Well, straight away I'm going to discount the first one because I know for well that's not going to be over 1. That's smaller than 1. 9 divided by 4 is 2.25, so it's not that one. 19 divided by 8 gives us 2.375, which is the one that we wanted. So 19 over 8 is the answer. Here's question 2. So here we're looking at inverse proportion or indirect proportion as it's sometimes called. So we've got that y is inversely proportional to x. So what we get from that is that y is linked but inversely, so that means k over x. This is the relationship between y and x. We need to try and find this value k, this constant value that links the two together. The way that we do that is start off by substituting in these two values here. So instead of saying y, we put 4.2 is equal to k, we're going to find this in a moment, over x, which it says is 3.5. So to try and find the value k here, we need to know what number divided by 3.5 equals 4.2. Well, we just rearrange this and actually multiply together 4.2 and 3.5. This will give us our value of k, which if you put into your calculator, 4.2 multiplied by 3.5 gives us an answer of 14.7. So k is 14.7. That now means that we can rearrange, or rewrite should I say, this equation here. So actually the real link between y and x is that y is equal to 14.7 divided by x. So what we can now do with our correct formula or correct equation is work out the actual bit that it's asking. So it says work out the value of y when x is 5.6. So what we do is to find y, we would do equals 14.7 divided by x, which it says is now 5.6. So I'll take my calculator and again I'm going to do the same. So 14.7 divided by 5.6, and it gives me an answer, if I change it to decimal, of 2.625. So 2.625. And there's my answer. Here's my next question. So what we need to do here is try and fully describe the transformation that changes, and here's where you need to be careful, A to B. Now it's a 3-mark question because there are 3 elements that we're going to need to write down. The first thing you get a mark for is for writing down the fact that this is an enlargement. The scale factor here, and this is one that people will normally get wrong on this question, is because we're going from A to B. So what I would need to do is look at the size of A compared to the size of B. Well, A along the bottom is 1, 2, 3 squares, B is just 1. Up the side it's 1, 2, 3, 4, 5, 6. And on the side of the small one it's 2. So we've got a scale factor of 1/3. Because it is 1/3 as big as this one. The third and final thing that you'll get a mark for is to find the centre. So where has it been enlarged about? In order to do this, what we need to do is join together corresponding corners to try and find the centre where it's been enlarged about. If you take a ruler, or in my case a pencil, and join together the corresponding corners and then extend the line, what you should find, if you do this with more than one corner, or if you do in fact with all three, is you should find that all the lines will join at the exact same point. In this case, down at the bottom, 0, 0. So that is known as the centre of enlargement. Here's your final question. So we've got a bit of working that we need to do on this question. Even though it's only a 3-mark question, we need to make sure we show every element of working because each bit will carry some sort of mark, and we'll guarantee that if we make a mistake later on, we don't lose anything too big. So the first thing we've got is that each sheet of paper is 7/1000ths of a centimetre thick. And the taller pile, this one here, we've been told is 10.5 centimetres high. Well, the first thing I'm going to do with that piece of information is actually work out how many sheets of paper there are in that pile. Well, if each sheet is this big, so 7/1000ths, and this is how big the pile is altogether, to find the number of sheets, I would have to do 10.5 or 10.5 divided by 7/1000ths. So in other words, to try and find out how many 7/1000ths there are in 10.5. Well, in order to do that, if you take your calculator, 10.5, which I'm just using to replace 10.5, divided by 7/1000ths gives us 1,500. So that tells us there are 1,500 sheets in the large pile. The question is wanting us to find how many sheets are in the shorter pile. Well, if the ratio between the tall and the short pile is 3:2, so must be the number of sheets, because each sheet is the same width at the top of the page, so the number of sheets must also be in the ratio 3:2. So if we use that idea, large to small is in the ratio 3:2. We know that the large pile has 1,500 sheets, so we just need to find out the number of the equivalent ratio for the short pile, or the small pile. Well, to get from 3 to 1,500, I've times by 500, so I'd do the same on this side, timesing by 500. 2 times 500 is 1,000, so in the shorter pile, there's a total of 1,000 sheets.